My name is Jennifer Van Ostrin, and on behalf of ACRL and Choice, I'd like to welcome you to today's program, Defining and Continuously Improving Relevance Ranking in Discovery Systems, sponsored by ProQuest and featuring Susan Price. Today's discussion is one in a series of sponsored webinars from ACRL and Choice that addresses new ideas, developments, and products of interest to the academic library community. Free to users, these structured 60-minute live presentations provide the opportunity for interactive discussions of important new issues and developments in academic librarianship. Before we get started, I'd like to point out a few features of the webinar software. In the main area of the screen, you can follow along with the presentation materials. Along the left-hand side, you will see a Q&A panel that you can use to submit questions or comments. Please feel free to submit these throughout. And finally, please note that today's program will be recorded and all registrants will receive follow-up instructions on how to access the archived version. And now for some background on today's speaker. Susan Price is a senior search analyst for ProQuest Workflow Solutions, where she has been a lead team member as well as measuring, monitoring, understanding, and predicting search traffic volume. After earning a PhD in tasks, Susan worked at Microsoft as a senior program manager in the SQL Server Database Group, working on query processing and column store technology. Her experience eventually brought her to ProQuest with the ambition of proving the discovery experience for library users worldwide through Summon. With that, I'd like to turn things over to Susan.
Thank you for the kind introduction, Jen. As Jen said, my name is Susan Price. I'm a senior search analyst at ProQuest, and I'm here today to talk about my favorite topic, which is relevance ranking. So first, I want to tell you what I would like to have you take away from this webinar. I hope that you will walk away knowing that relevance ranking is critical in web scale discovery, that multiple factors go into computing relevance ranking, that relevance ranking is a tough problem, and we can work continuously to improve relevance, and we're doing that here on the Summon team. So first, let's look at an example search. Imagine that you're looking for documents about Virginia Woolf. So how would the search engine rank documents about Virginia Woolf to display to you? Well, there are several options. And what if we chose the most recent documents that contain the terms Virginia Woolf? Recency works well for popular items. It may work well for news. It can work well in web search, but it's often not the best thing for scholarly search. Because a lot of times what you're looking for is details about a topic, perhaps classic research papers, and classical papers are often older documents. So if we just use recency, we're likely not to find the best or most important or most useful articles. So what about popularity? Well, again, popularity is not necessarily the best dimension for scholarly search. It may work very well for a typical web search. But the other problem is, what should be the metric of popularity for academic search? The document that's been clicked on the most, papers that have the most citations, the most anchor text links. Again, that works well for web search, but isn't very practical for academic search. Another option is to choose the documents that have the most mentions of Virginia Woolf. So if we just count up how many times the terms Virginia Woolf appears, we're going to tend to prefer longer documents, especially books. And that may or may not be what you or your user is looking for. Shorter articles like notes, poems, obituaries, etc. will tend to rank low just because they're short, and so they probably won't mention Virginia Woolf as often. Now, in some cases, that may be what you want. You might want to screen out some of those types of documents, but if you are looking for them, it can make it very difficult. And we know that there are some journals that publish very short articles, for example, in Nature, that are very important, have high impact, but tend to be short. And so just on the basis of length alone, they may have fewer mentions of the terms you're looking for. So let's look at a couple of examples. So this is a screenshot of what I found when I searched Google Scholar for Virginia Woolf. And if you look at the results, the thing that stands out to me the most is that all of them have V. Woolf as an author. None of these top results are actually about Virginia Woolf. They're all by Virginia Woolf. And again, with the query Virginia Woolf, you might be looking for things about Virginia Woolf, or you might be looking for things by Virginia Woolf. And given that, in this case, the documents that have been returned are all with Virginia Woolf as an author, or at least V. Woolf, it's not clear just looking at the results how the results were ranked. So all of them have fairly high citation counts, but they're not ordered strictly by citation count. And if you look at publication dates, they're not strictly ordered by date either. And we see that there are both books and citations, so they're not being ordered strictly by content type. So there's more going on than just one feature that is being ranked here. If we look at Microsoft Academic Search, we see something slightly different. First, we see that they have a notion of names, and they recognize that Virginia Woolf is a name, and they give you some options to try to disambiguate people who may have the same name. Now, in this case, they might all be the same Virginia Woolf. I didn't go look and see what's behind each of those links, but many times there are authors who have the same name but publish in completely different fields, and they do a pretty good job of clustering documents around different actual individuals. And the other thing that we notice here is that in some of these results, Virginia Woolf is in the title, and in some cases it's in the author's name, the author field. And so they brought back both kinds of documents. Again, the actual ranking algorithm is not obvious. It looks like they probably use citation counts. They probably use date, but neither one is being used primarily because they're not ordered strictly by date or strictly by citation count. So again, we can't really tell what their ranking algorithm is. Now, if we do the search in Summon, we see that Summon returns the top results all with Virginia Woolf in the title. So it appears that occurrence of the search terms in title are emphasized more than matches in the author field. And again, it doesn't look like it's strictly ordered by any one thing. On the right, you'll notice that there's a notion of topic as well. So not only do we have a list of search results, but there's an excerpt from a reference source that gives you a summary of a topic. And this is particularly helpful for new researchers who are maybe looking at a topic they're not very familiar with, and they just want something to help them get oriented. And there are also some related topics that they might be interested in searching on. So what I hope to convince you is that relevance is more than just aboutness. So aboutness is necessary. You want the documents returned to be about the topic of the search, but that's not enough. So relevance depends on more than just one feature. So we're going to be talking about what are the features that contribute to relevance, how do discovery engines combine those features, and then how does one continuously improve relevance. So that's what the rest of this talk is about. So what is relevance? So this picture shows a guy, probably an undergraduate student, and he needs to write a paper about the war in the Falklands. So what does he do? He types a query into the search box, in this case Falklands War, and he gets back a list of results. And that's typically the beginning of a search. So the way we tend to think about relevance is that it is how well do the search results meet the information needs of the user. And so there are a number of elements in this sentence. It means that relevance is subjective. It's contextual, so we have the context of a given user who has a particular information need at a particular moment in time. It's temporal because what you're looking for may change even when you put in the same query over time. The more you learn about a topic, the more you are looking for things that are perhaps have new information that you haven't already read, that has perhaps a deeper discussion now that you understand the basics. Relevance can be very difficult to find. We joke that it's a lot like pornography in that you know it when you see it. So you can look at a set of results after you put in a query, and you can say, okay, this document is relevant, that one's not. But it's hard to describe how something will or will not be relevant for every query, because it's going to change in the context of your query and your information needs, what you already know. And it's a satisficing function. That is, you're looking for something that's going to satisfy your information need. There's not just one perfect, relevant result that's going to be the best for everyone, or the perfect ranking algorithm that's going to be the best for everyone in every situation. There are a number of factors that come into play here. So what's the user intent? What's their level of knowledge and the depth of their interest? What's their particular information need, and what's the setting? Are they writing an essay for an undergraduate assignment? Are they a PhD student writing a dissertation? Do they need to find just one good document, or do they need to find everything? What kind of content type are they looking for? Do they want books? Do they want journal articles? Do they want news? And it's time dependent. So what I want today is not necessarily the thing that I would want, even putting in exactly the same query terms a month from now. So what do researchers want from a discovery engine? Well, obviously it's going to vary from person to person, but in general, people want ease of use. They want ease of access to the documents that are returned in the results list. They often want help exploring a new topic, but sometimes they're just looking for a known item. They know exactly what they're looking for, and they just want to find it. They may be looking for either result or content diversity. So in the case of the query term Virginia, that could refer to a person, or it could refer to the state. They may want different content types. So for example, they may want books, images, journal articles, ebooks, news, and they may want one or more of those in some combination, and it's going to vary. Source diversity may be important, so you might want things coming from multiple journals or newspapers, not all of them from the same thing. Source credibility tends to be particularly important in scholarly search. We emphasize results coming from scholarly materials as opposed to popular sources. Precision is always desirable, and by what I mean by that is that you want all of your results, especially the top ones, to be relevant to the search. But there's often a balance because sometimes you want to find all of the documents relevant to a particular topic. And we refer to that as recall. And there's typically a balance. The more precise your results are, the more you typically give up recall to make sure that you don't pull in things that aren't actually related. The more you try to get a high recall and cast a wider net to find everything, the more likely you are to sacrifice some of the precision. And with a discovery engine, like Summon, typically you are looking for results that may, you would like to have full text results, but you may also be interested in results from ANI sources that maybe you can find the text somewhere else. You may be interested in results within and across languages. So you might want your search to encompass not only one language, but also one or more other languages that may have important documents and that hopefully you're able to read. And typically we provide faceted search. So you may want to search on different fields like title, author, abstract. And then something that doesn't typically apply in web search but can be very important in academic search is that we need to respect digital rights. And so by default, most discovery engines will search the client's collections plus open access. So those are the things that the user can get to, that they have rights to. And then, for example, with Summon, you can then have it display everything that it knows about, even if your library doesn't have access to it. And then you can go and find other ways to get access to those documents. So let's talk a little bit about ranking. So just as a general outline of how discovery systems work is there are two main tasks. So given a query, you need to find all the documents that meet the search criteria, however you define those criteria. And then once you've found this big set of documents, you need to rank them because you want to provide, you only have so much screen real estate and people tend to look at the top first. So you want to rank documents in the order you think they are most likely to be of interest to the user. So we typically assign a score to documents based on the similarity to the query and some notion of the importance of the document so that we can return this ranked list of search results. So the first step, finding documents to be ranked, there are a couple of general options that search engines use. So one is a federated search where you send a query to multiple sources and you retrieve a ranked list from each source and then you merge the ranked lists. And the other option is a single unified index where you have all of the documents in one index, you send the query, and then it returns, it finds the matching documents and ranks them. And both of them have their challenges. With the federated search, when you get a ranked list from multiple sources, those lists are often not directly comparable because they may use different search engines with different features and scoring algorithms. And so you have to figure out how do you compare the top document from source A to source B. How do you rank those? And that can be a challenge to get it right. With the single unified index, you do that work up front, trying to get everything into one index and then have an algorithm that can handle all these different document types, give them a score based on the same algorithm for evaluating and scoring features, and then return a ranked list. So moving on to talk more specifically about ranking, typically what you want to do is to first identify features that contribute to whether something is relevant or not. figure out how to assign scores to each feature, and then combine the feature scores for each result to get an overall result relevance score, and then rank according to those scores. Now, of course, the devil is in the details, which is how do you identify which features are important, how do you assign scores, and how do you combine them? So we're going to talk in a little more depth about some of those features. The one people are probably most familiar with is word occurrences, so term frequency. And there's a general notion that the more times a term occurs in a document, the more likely that document is to be about the concept that that term represents. And so we mentioned that at the beginning, you can count term frequency. Now, along with that, there's a notion of inverse document frequency. And what we mean by that is that if you take a whole corpus of documents, for example, an index of all the documents in a discovery engine, the frequency of occurrence of that term across the entire corpus tends to indicate its ability to discriminate aboutness. So the more common a term is, the more documents it appears in, the less able that term is to discriminate what the different documents are about. And just for some general examples, the word "the" is going to be a very poor indicator. Almost every document in English anyway is going to have the word "the," and it doesn't tell you much about what the document is about if it has contain the word health. Diabetes is even more specific, and it's going to occur in fewer documents, and is going to be a better discriminator of whether that document is about a topic related to diabetes or not. That combination of term frequency, or TF, times the inverse document frequency, IDF, is one of the most common notions for ranking in information retrieval field. It's been used for a long time. It's very common. Another common concept is that of the stop word. So we tend to ignore common words. In English, words like a and the. Each language has its own set of these very common words that don't tell you much about what a document's about. And typically what we do is to ignore those words, and that's why they're called stop words, or some people have called them noise words. Now, a good search engine will also have special handling in the case where there are multiple stop words, because just think about the title, "To Be or Not to Be." Every one of the words in that title is probably going to be on your list of stop words to be ignored, but if you ignore all of them, you're not going to find anything for that query. So you have to have some sort of special handling in cases like this. The who is another example. Another concept is synonym mapping and synonym expansion. So think about the different ways of spelling words in American English versus UK English. So theater, R-E, or theater, ER. We want to make sure that if the query uses one of those, it will match documents that use the other spelling variation. Similarly, Strasse using the character that looks like a large B versus the double S. And each language will have its set of alternates that you want to be able to map. Synonym expansion, you might take something like a query for heart attack and expand it to also find documents that contain the terms myocardial infarction, which is the more medical term for a heart attack. So you want to identify pairs of synonyms that are close enough that you want to be able to expand your search to include. If you do that too aggressively, you're going to improve your recall. You're going to find more documents about that concept that's represented by either heart attack or myocardial infarction, but you're probably also going to find more things that aren't relevant, and so you're going to hurt your precision. So you have to be careful about doing just enough expansion but not too much. You need to find a balance there. Stemming, so we want to be able to match a query for cat to documents that contain the plural or cats. And again, there are many examples there in English but also in other languages. But you want to, again, be careful because you might want to rank exact matches above the stemmed matches. So for example, if I'm searching on the word apple, expanding it to apples might be what I'm looking for if I'm looking for fruit, but if I'm looking for the company Apple that makes iPhones, maybe I don't want that expansion. So often you may find some differential ranking where an exact match is more important than a stemmed match. Many languages contain special characters with diacritics, and some documents may use the special characters and others don't. Some characters map to multiple alternative characters. In Chinese, you have both the simplified and traditional characters, so you need to be able to map between these so that you can match your query to the documents. We have a notion of tokens, which is actually what gets indexed. And in most languages, like English, we do white space tokenization, meaning that we take the query and split it into words based on white space separation. And that works great for English, but there are some languages, for example, Chinese, Japanese, and Thai, that do not use white spaces to indicate word boundaries. So you have to handle those a little differently. And you can either tokenize based on individual characters, or there are some complicated algorithms for word segmentation. And you can also use a combination of approaches. And I'm not going to get into details here because I'm not an expert in these languages, but I can tell you that someone uses a combination. Decompounding is another important thing when working with multiple languages. So some languages like German have compound words, and there's an example here on the slide which I'm not going to even attempt to pronounce. But let's see. I looked this up in a translating application, and it said beef meat labeling parent monitoring task transfer law. So I'm sure there's a much better way to describe that concept, but if you want to match that to documents that contain the concept that's represented there, you need to be able to split that compound word into its parts. Another example that's a little bit easier to imagine is a query for Kapitan patent should match the compound word in German for captain's license. So another interesting thing is the different fields that you have for a document, which contain different types of information. So for example, you have a title, an abstract, author names, and you might want to weight those fields differently. So typically a word in the title is a better indicator of what that document is about than the same word occurring in the abstract or the body of the document. So a match from a query word to a word in the title is usually weighted more heavily than when that word only occurs somewhere else in the document. And discovery systems typically contain a lot of different content types, and you might want to weight those differently. So for any given search, is a book better than a journal article? Is a journal article better than a newspaper article? And for many searches, the answer to that might be yes, but always? And how do you know what it is that your user is looking for? The utility for a given content type is going to depend on the information need of the individual user who has entered that query. And in some cases, even the user may not know what content she's expecting. So your algorithm, which knows nothing about the individual user who's submitting that query, has to achieve some sort of balance of what is most likely to be useful to most searchers for most queries when it comes to content type. So publication date is another feature that we look at. We say all things being equal, a more recent document is usually more valuable than an older document. But is it? Or is it always more valuable? So what about classic articles and books? They tend to be older, but they're classic because they passed the test of time. Lots of people have read them, have said they're important. So you want to make sure that you don't ignore those classics. And if you just use publication date, you're going to end up with a lot of book reviews appearing higher than the book that's being reviewed, because the book review is typically published after the book. And then you have to figure out how to handle documents that don't have a publication date. I mean, obviously there was a date on which they were published, but it may not be available in the metadata that you have for that document. And again, all things being equal, highly cited articles are generally more valuable. But think about how citations happen. Older articles are more likely to have more citations because it takes time for the citing articles to be published. If I publish a paper and it has all this, really important data and conclusions, it's going to take a while for you to read that paper, write your own paper that cites my paper, and get it published. So there's a lag time there. So if you just look at citation counts, you're going to discriminate against the more recent articles. Scholarly and peer-reviewed articles are usually more valuable in the context of an academic discovery engine. But that means you have to have accurate data regarding which publications are actually scholarly and peer-reviewed. And sometimes that data is a bit messy. And then how do you handle things like poems, news, obituaries, letters to the editor that are published in scholarly journals? So if you know this is a scholarly journal, then you're going to assume that all the documents in that journal are scholarly. And that's going to be true for the peer-reviewed articles published in that journal. But that means that things like obituary, little news columns, poems, things like that are also going to be labeled as scholarly. And so all things being equal, we would prefer X. But the truth is all things are almost never equal. So we can't just rate different features in isolation. But we can weight various factors and then figure out how to combine those factors given the weights. But how do we do that? I mean, there are a number of options. We can use intuition, which is kind of what we've been talking about, saying, well, all things being equal, I would prefer X. You could use some sort of machine learning, saying, this is what people click on. You could use A/B testing, where you present different results to different people, or present two different lists to the same person and see what they prefer or what they click on. You can adjust your algorithms according to user feedback, or most likely you use a combination of the above. But it's hard to always get it right, because one algorithm isn't going to make everyone happy on every single search. So that's a segue into the next thing I want to talk about, is why ranking is not trivial. So what results do you expect if you put in the query Amazon? Let's see. That poll is actually for the next example. So let's come back to that. So if I put in the query Amazon, I might expect to see results about the Amazon River. But what do I want to know about the river? And it's going to vary from person to person. You might also be expecting results about Amazon.com. But again, what aspect of Amazon.com should be displayed first? What about female warriors from Greek mythology? Or there might be other things that the word Amazon, other concepts that the word Amazon might represent. So let's look at another example. Suppose you're a discovery system and you receive the query Ukraine. So what would you return as the top document? And in the poll at the top of your screen, we have several options. So take a moment to put in what you think the search engine should return. And I'll just wait a few seconds and give people a chance to think about this and participate in the poll. Okay, I think we're seeing pretty consistent results here, which is that people don't agree. So the top two things are definitely the most interesting, or interesting to the most people, but we have about a third saying they want news about current events in Ukraine, and about two-thirds saying they want information about Ukraine, such as history, geography, and economy. Now, of course, Ukraine's been in the news a lot recently, and so your answer to this might change if instead of Ukraine, I put in a different country name. Let's say, I don't know, Costa Rica. Would your answer change? It might very well. You might very well expect information about history, geography, and economy rather than news. Okay, let's look at another example. Suppose you're a discovery system and you get a query, and you, as the computer, you don't know what that query actually means. So you have to decide, based on what you know about the documents that match the query, how to rank them. So take a minute to look at the information you have here and pick what you would rank first. So all of them, the title matches the query. We have different content types, different publication dates, and whether or not the document is in the institutional repository. Okay, I know there's some people out there who haven't voted, so give just a little bit more time for people to read the answers and take a vote. Okay, it looks like over 80% are choosing the second option, which is a journal article that was published in 2014, although it's not in the institutional repository. So now what if I were to tell you that the query was Gone with the Wind? Would that change which one you would select, knowing that the first document is Gone with the Wind, Impacts of Wind Turbines on Trade. I won't read the whole title. The second article is, I think that was the one that's in, thank you, in the journal Cosmetics. That was the journal article published in 2014. The third one is the book by Margaret Mitchell, published in 1976. And the fourth one is Gone with the Wind, published in Nature, about the theory of galaxy formation. So knowing what the query is, you would probably select the third option to be the one that you would rank first. But just based on knowing that it's a book published in 1976, that's probably not the one that you would choose. So another interesting one is known item searches. So researchers often are looking for a particular book and article that they either know about, they've read it before, or maybe it was cited in another paper they've read. So how does the search engine know whether a query is exploratory or a known item search? Well, it doesn't. It doesn't know the intent of your query, although if you give it more information, that helps a lot. So most discovery engines are going to have an advanced search interface where you can indicate that you're looking for something in the title or in the author name, maybe give it a publication date. And these work really well, but they're rarely used. Most of our users do not use advanced search interfaces. So the search engine has to figure out how to make the best of what it can with the query that it finds in the search box. You know, as humans, we can look at the query and recognize these examples that I have here as being searches for known items. So Common Sense, Thomas Paine, Hemingway, For Whom the Bell Tolls, some things that look like they are citations that were just pasted into the search box. But the question is, how does the search engine figure out how to deal with those things? So for example, how do we know that the author in the last one is actually not Princess Margaret, but anonymous? What do we do with a bunch of numbers? How do we know what date? Don't match anything in the information we have because our metadata is incomplete, or maybe it's represented differently. Maybe instead of we have the name of the month versus a number. There are a lot of things that make known item searches, particularly these pasted in citations, particularly challenging. If you look at the third example, somebody's pasted in also, that's probably that number 35 followed by a period is probably just copying and pasting from a list of citations. So just in summary, ranking is non-trivial for a number of reasons. One query can represent multiple information needs. The user may want classic books and articles, or they may want the latest research. Different users have different levels of knowledge and sophistication for a given topic. So you might have a freshman putting in the same query as a graduate student writing a dissertation, but they have very different levels of knowledge, and what they're actually looking for, what will satisfy their search, may be very different. Users may want more resources of one type, or they may want more diversity. They may want only resources that are locally available, or they may want to find everything that exists, whether it's going to be difficult to find or not. Many queries can represent a search for the same known item. People type them in very different ways, format their citations differently. So we need to balance multiple factors that affect relevance. And the relevance features are highly interconnected. So if we change one feature in a relevance algorithm in isolation, it's going to cause unintended consequences. And it's very easy to get pulled into a whack-a-mole situation. If you look at the picture on the right, I don't know how many of you have ever seen this game, but you have a mallet and you whack the mole poking up from one hole only to have it reappear in a different hole. So we have to be very careful about trying to fix examples of unsatisfactory results for one query to keep from messing up the results in other queries. We have to take a very holistic approach to relevance. So how do we know if we got it right? So we return a list of results, and we have to figure out, well, how good is our relevance? And there are a number of things that you can do. So one is to examine for a particular query how the score was computed. So why was document A ranked above document B? We can also look at how things are ranked by different versions of the ranking code. So if we make a change to our algorithm and put in query A, which ranked list looks better? There's some things we can do to plot relevance scores for different algorithms. So changing different things like publication date or citation count or degree of similarity and actually plot that out on a graph. We can calculate relevance metrics, and there are a lot of metrics out there that have been published in the information retrieval literature. The problem is that we typically don't have users telling us which documents we returned are relevant to them and which ones are not. We can use clicks as a proxy for relevance with the idea that if someone didn't click on it, it probably wasn't relevant, or at least it wasn't useful to them because if they didn't see it, they didn't use it. It's certainly true that clicking on a document does not mean that it is relevant because obviously you click on way more things than you actually use. So that's a very imperfect proxy, but sometimes it's useful anyway. We can perform A/B testing where we funnel some user queries to a new version of the code and compare metrics and say, hey, it looks like the new code is functioning better than the old, or at least it's not worse, because typically changes are targeted against a small subset of queries, and you just want to make sure that you're not making everything worse as a side effect. And then, of course, user feedback. And we use all of those things with the goal of continuously improving relevance. With Summon, we are actively improving known item searching. I think that's a particular weakness in most discovery search engines. A year or two ago, we improved the results that included both a title and a subtitle. And very recently, when I first made this slide, this said that improvements for more query types will be evident soon, but it's actually now as of our release last week. So you should be seeing better results if you put in title plus author or title plus subtitle plus author, title plus publication date for journal articles, and various other things, and various combinations of these fields. In all cases, your results are likely to be best if you put in at least part of the title in the query. But you can now add a number of other elements and see much better results than you did in the past. And we are continuing to work on this. You can expect to see improvements for queries containing full citations, not just the elements that I listed above, coming soon. And then you as the user also has a role. So you can help us by submitting detailed feedback on what you expect and what you see. But when you do that, keep in mind some of the things that we've talked about today. Think about why your expectations might not be met. And one of the more common ones is that people complain about not finding something in the results because the library doesn't have rights to that result. And unless you expand your query to include everything, you may not see it. Documents often don't have the terms that you expect. People use different words. And of course, all features have trade-offs. So we talked about recent articles versus classics. We talked about how exact match on the title is great for known item search, but sometimes that can dominate your results if you're looking for documents about a topic, but you don't necessarily need an exact match in the title. So your feedback really helps us to find the right balance in combining all these different features that we use. So other ways that we can improve the research experience is to provide more than a ranked list. So we provide tools to help the researcher understand the area he's beginning to learn about, tools to help express that information need more fully. Our users tend to use very short queries that don't really convey what it is they're looking for. We can help you refine the search, applying filters, and explore multiple content types. I want to allow some time for questions, but just briefly, here's some elements of the Summon user interface that is more than just the ranked list. So on the left, you can see that you can apply filters to your results. We recommend different databases you might want to look in. We have the topics, which I mentioned before, that give you a little synopsis of the topic if you're just getting started. It can tell you which librarian at your library can be most helpful to you, and suggest some related topics and research guides. We also have a feature that will cluster all of the results of certain content types into one result so that it doesn't take up your entire screen real estate, but you can click and explore it more fully. So for example, if you want to look at images, it only takes up one of the items in your top 10 list, but you can expand it if what you're really interested in is images, and we do the same for news. And also suggesting other searches that might be of interest to you. So again, takeaway messages. Relevance ranking is critical. Multiple factors go into computing relevance ranking. Relevance is a tough problem, but we can and are continuously working to improve it. So I want to thank you for attending the webinar today. It was my pleasure to talk to you all, even though I can't see you face to face. I would like to also thank the Summon team members, particularly Kaz, Chandra, Ted, Brent, Scott, and Steve. And with that, I'm going to turn it over to Scott, who is going to moderate questions.
Thank you very much, Susan. We've got a few questions into the Q&A panel. The first question is, can you clarify recall versus precision?
Sure. So that is terminology that's often used in the information retrieval community. And what it means is, so precision is, it's actually defined as the percentage of results that are actually relevant using some sort of criteria for judging relevance to the result. So let's say if a search engine returns 10 results and 6 of them are relevant, then your precision would be 60%. Recall is the fraction of all possible results that are relevant to your query that are actually returned. So if I only return to you 10 results and there are 20 results out there that are relevant, and out there might be defined as present in your index, or it might be the whole world, however you want to define your problem, your recall would be 50% because 10 out of 20 or 50% of all relevant documents were returned in the top, you can say in the top N or returned at all, depending on how you want to define it. But we'll just use 10 results for now.
Okay, the next question is, should subject headings weigh more than the title?
So that's a good question, and that fits into a lot of things that I was saying about finding balance. So in some subject terms actually act a lot like query expansion. So you're trying to map your query term instead of aboutness as determined by the title and the frequency of occurrence in those terms to whether it matches a subject term. And for some queries, subject terms can be very helpful. It works like a synonym expansion to find documents that are relevant, but it can also cause some negative side effects because it can, like query expansion that's done too aggressively, it can return to you a bunch of stuff that's not at all related to what you're looking for. So it's, the answer is yes, it can be helpful, and yes, it can also be harmful, and it's going to vary a lot. We tend to think that it can be, it can often mess up your query results if you're not careful.
Okay, we have a few questions. They're along the same topic. As a summon user, do we have any control over the search relevancy, or is direct feedback to ProQuest the only option?
Direct feedback to ProQuest is definitely the best option. We don't now offer control because it actually makes the whole thing much more complex. And if we put our efforts into creating an API which allows you to control all these things, that's less effort than we can put into actually making the relevance better. And we actually believe that having a dedicated team who spend basically all their time thinking about search relevance are going to do a better job than having individual librarians try to craft their own relevance algorithms.
Okay. Next question is the use of quotation marks around a phrase in a title, for example, to find a known item, a universal strategy that works with all search engines? If so, wouldn't that help with returning known items sought in a query?
So using quotation marks to indicate a phrase does work in most search engines. It works in Summon, and it indicates that I want to see those words together. And it will help you find a known item. Now, the problem that you run into is that it will help you find a known item if you're just searching in the title. But if you're searching in multiple fields and you put them all within the quotations, then you're not going to find all of those terms for an entire citation in a single field. So if you put in Thomas Paine common sense all within quotations, that phrase is never going to appear anywhere, and so you're not going to get a match. So again, you have to be careful how you use them, but they can be very useful.
Okay. Next question, does Summon ranking favor results from ProQuest products over others? How is Summon ranking impacted by vendor?
Summon throws everything into the same index, and we don't have a notion of publisher or vendor as a feature to influence ranking. Now you will see there are a lot of ProQuest things that come back because there are a lot of ProQuest documents in the index, but they're not being preferred over other documents.
Okay. Next question is, you use broad concepts for your search examples rather than natural language. How does using these different search methods impact relevance?
That's a good question too. Again, it's going to depend a lot on the actual query and the information need. If I put in a natural language query and there is a title that has a very close match, you'll get great results. But natural language queries tend to have a lot of stop words, and those tend to get disregarded for the most part. I should note, I talked about exact match and word frequency, but there's actually more of a spectrum there where we give preference if you get an exact match to the query. Even if you haven't put it in quotations, you'll get that phrase will tend to get preferred. And if your query terms appear close together, they're also likely to get preferred. So even if you haven't put it into a natural language query, if it fits into the natural language in the document, it's more likely to come back.
Okay, we have a couple more minutes left, so a couple more questions. What about more traditional keyword searching? Have you done testing to see how results compare on similar queries searched by relevance and keyword? Relevance tends to give better results in the top 5 to 10, but then relevance seems to drop off while with keyword, there seems to be more relevant documents retrieved overall.
I'm not sure what the question is, what is meant by keyword. So when I think of keyword, I think of whatever terms are in the query. Oh, I got it. You're talking about keywords used in the as an indexing term in the document, sort of like an indexing term. Okay, so those will match if they match to the query and they're present in the metadata that we have about the document. they're not as highly preferred as matching on title. But they are included in the ranking algorithm. Sorry, it took me a minute to realize what you were talking about.
No worries, Stephen. If that didn't answer the question, we can connect with you offline. Um, next question and last question. If you have any questions and we get to them, please email Susan at susan.price@proquest.com. When you are getting user feedback, do you factor in relevant versus pertinent?
So we don't get a lot of feedback in terms of from the end users. We typically get it from our librarian clients. And so we typically get a little bit more nuanced feedback as opposed to just saying relevant, not relevant, or pertinent, not pertinent.
Perfect. Thanks a lot, Susan.
Okay, looks like we're ready to wrap up today. I want to thank Susan for joining us and sharing some great information. And as a reminder, we have recorded today's program, so please be on the lookout for a follow-up email from ACRL and Choice that will include instructions on how to access the archived version. And thanks again to all our participants for joining us. I hope you enjoyed this